Good morning, good afternoon, good evening, everyone, and welcome at the Global AI Talks Live.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Ik zit Sammy in België.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I'm Tess. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，Nederland.
I'm Rafat Aziz from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Amrita Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm Joe Spizak from California. Hi, Mehdi Ebi Daoud from Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
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 Hi, everyone, and welcome at another episode of AI Talks Live. As every week, we have a guest speaker, and this week we have someone from the global AI community itself, Willem Meints. Thank you for joining us.
Yeah, thank you for having me. Happy to be here. It's actually the first time I'm presenting an AI talk during our live sessions on YouTube, so I'm pretty excited.
Well, we need to give everyone a chance, so also you.
Yeah, normally I'm the guy that's organizing stuff, so this is quite different.
This is indeed a different way. But Willem, for the ones who do not know you, just introduce yourself, please.
Yeah, so I'm Willem. I work for InfoSupport as a technology advocate. My daily job is actually helping teams get started with stuff like AI, machine learning, data platforms like Azure Synapse, that sort of stuff. But in my spare time, I spend, I think, almost every hour that I have on the global AI community and helping people get AI knowledge across to others that they work with, friends, colleagues, students, almost everybody, I think. And it's quite fun to see all the good stuff that we're doing in the AI community. So, yeah.
And I'm sure everyone appreciates what you're doing also for the community. So, small applause.
Yeah, so yesterday I got my fifth MVP award. So it goes to show that people seem to like what I'm doing. And but the most important thing, I think, is that people get a chance to learn from each other in an open environment as possible. So yes, I do hope that people like that.
Well, that's a nice thing also about the community, sharing knowledge with each other, not for the money or not for the fame, just because you want to get to know more people, get to know more, and so on. And the community, it's nice. For me also, I've got to know so many more people lately. So that's really awesome. Well, we're not here to talk about ourselves today. You are going to talk about one of the new stuff from Build 2020, and that's Fairlearn. Small introduction to it?
Yeah, so we're going to do a short introduction on Fairlearn. People who've seen my session on Build may have seen some of the stuff that I'm about to show, but this time we're going to dive in a little bit deeper, and I'll explain a little bit more of the background around the package called Fairlearn and how you can use that to actually improve model fairness. So, yeah.
Okay, cool. Well, let me share your screen. Here you go. The platform is yours.
Cool. Thank you very much. So today we're going to talk about Fairlearn, a Python package that to me is the secret to teaching your models to play fair. And we're going to talk about what is model fairness in a minute, but it's good to know that this is fairly new. It's still in preview. So some of the stuff that I will show you is likely to go to change in the future. But nonetheless, it's interesting, especially since it's quite easy actually to use in your own project. Model fairness is not the easiest topics in the world, so I think it's nice to have a tool like this. So I've just introduced myself. I work for InfoSupport. If you want to reach out to me, you can reach me on Twitter, on LinkedIn, or on our Global AI Slack channels if you are on there. So let's move on quickly.
Add the S to your email.
Is it missing in my email address? No, it's not missing.
Info upward.
Oh yes, there's an S missing. Haha, people can't email me. Oh, that's a good one. Yeah. So you can still reach me on Twitter. That's fine. So as with any session, these are the topics that I'm going to cover. We're going to talk about model fairness. What is it actually? That's an interesting question because it means so many different things to people. So let's talk about that. Afterwards, I'm going to show you how to use Fairlearn to measure model fairness. So how well is my model doing? And finally, I'm going to show you how to improve the fairness of your models using Fairlearn. So that also goes to show that Fairlearn actually helps you both in measuring fairness and solving fairness problems. So let's talk about model fairness. Before I dive into all the technical terms, in this session, I'm using a demo that's from based on an open data set, but I invented a personal credit card company, Bits and Dollars Limited. And it has a tagline, not sure if you're going to get the credit, because it's a machine learning based company. And they are using machine learning specifically to determine who should get a credit card. And in this case, they are using a defaulters model. That means this model is going to predict whether you are going to default your next credit card payment. So the bill arrives on your doorstep and you're not going to pay. That's basically what it's going to predict. And if it predicts that you're not going to pay for your credit card bill, you're not going to get a credit card with this company. But if it predicts that you're going to pay the bill next month, then you will get a credit card. So that's how they do it. Whether that's a good thing, I don't know, but it's a new credit card company and they have to get some experience. I mean, you got to start somewhere, I guess, in 2020. But that's the way it is. So you will see me show off all the stuff that they have in machine learning models. And of course, this is a fake company, so don't worry about trying to find them on the internet. So one of the topics that is important in machine learning is model fairness. So most companies, as this credit card company is doing as well, they are spending a lot of time building the best model they can, and that means the best performance. So in the case of predicting whether someone is going to pay their credit card bill or not, it means that they are going to look at how accurate is this model. When we predict 100 cases, when we look at 100 different credit card applications, how many of those are correctly predicted as a defaulter or not? And that's fine for the most part, but there are a few problems. What could happen is that your model is going to exclude certain people. And in this case, it could well be that I request a credit card as an individual, and I get, yes, you can get a credit card, but somebody else that looks like me might not get a credit card, despite the fact that he has very similar behavior than that I have. In this case, we're talking about fairness toward individuals. So we have two people that look alike, but the model is excluding one person over the other, while there is no reason to do so. The other type of fairness that's important to keep in mind when building a model like this is group fairness. And group fairness is everything related to excluding groups of people. So, for example, this credit card company, Bits and Dollars, noticed while testing their model that female persons, so women, are more likely to get a credit card than men. And they don't know why. They are not even sure that it happens. So that's kind of funny. And they want to look into that. So today we're going to focus on group fairness. And that's for a reason, because Fairlearn as a package is only usable in scenarios where you have to deal with group fairness. So in short, you want your model to perform equal for all the groups of individuals that are using your model. So that may be based on gender, that may be based on age, that may be based on ethnicity if you have if you're dealing with that kind of issue. So that's the sort of stuff that you have to think about when you're looking at machine learning models and you want to use Fairlearn. So we're going to focus on that. And in this case, we're going to look at the problem that Bits and Dollars has, that women are more likely to get a credit card than men. And they want to find out why, and they want to fix that problem. So let's take a look and dive into some code. What I've done, I've created a nice set of notebooks. in which I train the model. I prepare some data, and we're going to look at measuring. So what I will do first is I will talk you through what I did to train the model, so you have an idea of what it looks like and what we're dealing with. And then we'll look at measuring fairness and see how well my model is actually doing when we look at men versus women. So let's start by looking at the training script. So anybody who's done machine learning knows that there's a package called scikit-learn in Python that you can use for building machine learning models. And another interesting package that people will have heard about is pandas. And I'm using both pandas for working with my dataset and scikit-learn for training my model. So in this notebook, I do a couple of things. So first, we'll load up the dataset and pre-process it so it is usable for machine learning in this case. Then we'll train the model. As a good scientist, I'm also looking at model performance. So I'm going to look at accuracy in this case. And finally, I'm going to make sure that I can deploy to production. So I'll save the model to disk. So loading and splitting the dataset in Python. You can use pandas in this case to load your dataset from a CSV file, like I'm doing here, but it also supports other data sources. Bits and dollars has their data stored in a CSV file. And I created a training set just for the purposes of this demo. What I do here is that I split this dataset into two pieces. So I set aside 30% of my dataset for validation later. One of the problems that you will run into in machine learning models is that when you train the model, the machine learning tries to cheat on you, and it tries to remember the samples that it has seen. And that's not what you want. What you actually want is you want to learn the rules that connect the input that you provide, the sample, to the expected output, the target. But you can't see that because the computer just tries a random thing, and then from there it works towards a good solution. So in this case, what I want to do is make sure that when I test my model for the fact that it has learned rules, I need to have a separate data set. So in this case, I'm using 30% of my data set as a test set. I'm never going to show the machine learning model that during training, so I can be sure that it's a good sample. This is random, so it makes a random selection of my data set just to be sure that I don't show the same samples over and over again. So that's also good to know. So what I do for machine learning here, for pre-processing, is I need to select a bunch of features from my dataset to train my model on. I can show you what features are in the model. So let's execute these two cells first. And then let's see. Let's pull up a few rows of data. So in my dataset, there's an ID column. There's a balance limit column, gender, education, marriage, age, and payment history. These columns here are actually the most interesting. These, as you can imagine, are pretty sensitive. So in my case, because I included gender, education, and marriage in my data model, we can be sure that there's something going to happen with the model. It's going to cheat on us in the sense that it will be unfair when we train this. But let's for now leave it at this and say, well, I know that gender is sensitive. I don't want that. And maybe ID column as well. I will add that here. And use the rest of the features as they are. And of course, if I create training samples, I have to include the target column as well. In this case, this column, default payment next month, is going to predict whether someone is going to default or not. So I don't want to include that in the sample because it will learn this column by heart, and I've got no machine learning model in the end. So that's what I'm doing here. So when I execute this, I've got a training samples for my model. And I've got the test samples for my model. So that's what's happening here.
Willem, can you zoom in your screen a little bit?
Sure, yeah, I can do that.
It makes it a bit more readable for the audience.
Is this better for you?
Yeah, it's better.
Ah, awesome. Yeah. With full HD these days, it's quite hard to see on camera. So next to these samples, I need to also grab the training targets and test targets, which only include the column that I mentioned. That's the default next month column. So that's what's happening here. So I can execute that as well. And what we're going to do is we're going to train a random forest classifier. Why a random forest classifier? Well, the data scientists at Bits and Dollars decided that this would be the best model for their purpose. So they run a few tests, and this turned out to be the best model. So yes, there's no better explanation for that. So I'm training this model. This will take a second to run, and out comes a model that should be working fine. So let's see if it works. So the next step, we've just trained our model. Now we're going to look at validation. And I'm looking at accuracy, and I'm thinking 83%. Well, it's not the best model in the world. I think we can do better, but okay, it's at least something. Let's keep it at that. And the second method of validation that I'm using here is a receiver operator curve, and this tells me how well my model is going to distinguish between actual cases of defaulters or false positives. So when I check this, I look at this chart in this way. So there's a diagonal line you can draw through this chart, and that's random. So it does basically nothing. If the curve is above that, in the top left, in the corner, then it's perfect, but we don't get there. So in this case, I can see this confirms my accuracy measurement that it's sort of okay. Finally, I'm saving the model to disk in a binary file using joblib, which is a serialization library for Python. And now I can move on to checking my model fairness. So far so good. It's actually working. That's nice. Let's see what happens when we look at fairness. So in this case, we're going to use Fairlearn, a Python package that you can get from this website, fairlearn.org. This is a package invented by Microsoft and a couple of data scientists. And what it allows you to do is measure fairness using fairness metrics. I will talk about those in a second, what those are. And it allows you to mitigate unfair behavior of your model to a certain extent. It's not going to be perfect, but it's at least something that you can do. And they've got quite a nice user guide that will help you get started. So they've got a quick start where you can learn to use this in a few minutes. So under this quick start. And then they've got a full guide that explains how to measure fairness, what is fairness, and certain metrics that you can use. So that's quite cool. So let me show you what it looks like in code. So what I have to do first is I have to load up my model again, because that's what we're going to look at. And I have to load my testing data set, which is another data set that I created specifically for the goal of measuring model fairness. Why? I want to make sure that nobody ever used this data set for training the model. Otherwise, I would get a sort of skewed output of my measurement process, and it wouldn't be the real unfair behavior of the model. So data scientists can use my training set and split that in a validation set and another training set, but they never can touch my testing data set. That's for me as an auditor or somebody that's going to validate their work. So after we've loaded the test data set, we can start measuring fairness using the Fairlearn dashboard. So let's load up the model using joblib again. So my model is now in memory. Next, I'll have to load the data set. So we're using pandas in this case again. And as you can see, it has the same shape as before because it's a subset of that. Now let's look at the Fairlearn dashboard. So Fairlearn contains a module called widgets. And within this widget module, you can find the Fairlearn dashboard. This Fairlearn dashboard only works within Jupyter notebooks. It renders a piece of HTML in this notebook that you can look at and then use. It's interactive. So if you're using pure Python, I'm really sorry, but it doesn't work. What you can do, however, is use the metrics separately without the dashboard. It's a lot harder, but it's doable. So let's see what we have to do here. What I have to do is, in order to use this Fairlearn dashboard, I have to import it, obviously. But I also have to create a new instance of this Fairlearn dashboard and feed it a couple of things. So the first thing that we have to feed it is sensitive features. These are features that you know or think you know that identify groups within the total set of users of your model. In this case, I know that the gender column in my dataset identifies 2 groups of people that I know that the model is unfair towards. We know this from user testing. But yeah, in other cases where you don't know, it's fair to say that things like gender, age, education level, marriage, status, that sort of thing is very sensitive. I have to say that in the case of bits and dollars, they already thought about this a little bit and said, well, maybe gender is a bad idea to include in the training samples. But despite that fact, you will see that they have some problems here. So in this case, I'm providing the samples for the gender column. In addition to this, I have to name those columns. Otherwise, Fairlearn will decide on the name by itself, and that would look kind of silly. It says column 0 of anything of that nature. So then we have to provide the ground truth of our model. This is the expected outcome of the model. And finally, we provide the predicted outputs of the model. What will happen is when I invoke this code, it will render the dashboard and we'll get there. But first, I have to do something here is say predicted outcomes. I can only come by those by calling predict on my model and feeding in some test samples. So, and the ground truth I also have to get from my testing data set. So let's execute that first. And then when I execute the Fairlearn dashboard, I get the following page. So it's slightly large on the screen, but that's fine. Fairlearn dashboard has 2 steps in it. So the first step is you have to select sensitive features that you want to look at, that you want to know, include in your analysis for group fairness. Then the second step is that you have to select a performance metric that you want to look at while measuring the fairness. So let's get started and see what that looks like. So first, I have to select a feature that identifies groups in my dataset. So in this case, gender has 2 subgroups. Value 1 is male, value 2 is female. I didn't bother pre-processing this data back to string values. It makes it all weird, so you will have to get used to this. I sometimes confuse myself in saying, oh, was it female 1? I don't know, but I know. I wrote it down before the session, so I can always look it up. So once I've selected my sensitive feature, I can look at the performance metric. And the performance metric in this case is, you can choose anything you want in this one, but it depends largely on the model that you're working on. So I chose accuracy because that's the metric that I used before for measuring performance of my model. My suggestion would be if you're looking at one of these metrics during training for validation purposes, then do the same over here. It makes it easier to compare the performance before and after fixing the fairness problem. And it makes it easier to relay the performance that you see in this dashboard to the one that you've seen during training. So that's important to keep in mind. So I chose, in my training notebook, I chose accuracy. You can't see that here, but I know for a fact that the score method on a scikit-learn model for a random forest classifier is accuracy. You'd have to look at the documentation to know for sure. So I'm choosing accuracy, clicking next. And what I get is a nice and shiny dashboard that shows a lot of graphs. And at first you might think, what the heck is going on? What is he doing? I don't get it. Disparity in performance. That was my reaction at first, at least. I was like, what does it all mean? It makes it really hard. But this is data science stuff. And it's quite hard at first, but let me talk you through it. So there's two things, disparity in performance, and there's disparity in predictions. I'll start at the top, disparity in performance. So what happens is Fairlearn splits my dataset in two groups, male, value 1, and female. And then what it did, it calculated the accuracy for each of these groups. And for male users, the accuracy was 88%. For female users, it was 79.7%. This means, in this case, that the model is doing better for male users and worse for female users. But there's another interesting part to this graph that I'd like to point out. Because from these numbers alone, you could say, why does bits and dollars have a problem? They are saying that it's more likely for a woman to get a credit card than a man, but that's not true because the accuracy of the model for male users, for men, is better than for women, but that's not true. Look at this graph. What you see here is over-prediction and under-prediction. So what does that mean? In this case, for over-prediction, for a male user, the model predicted 1, but should have predicted 0. So in 2.4% of the cases, the model predicted that a male was a defaulter, but it actually wasn't. In 9.6% of the cases, it predicted that a male user was not a defaulter, but it should have been a defaulter in that case. For female users, it's a lot worse. So in 16% of the cases, a woman is going to get a credit card while it's not a good idea to do so. In 4.5%, a woman is not getting a credit card, but it was a good idea to do so. So in this case, you could say it's easier for a woman to get a credit card versus a man, solely based on the difference in performance. We could argue about fairness in this case, saying, well, is that a bad thing? I don't know. It depends on the context of the project that you're working on. But in this case, for bits and dollars, it means that they are particularly harsh on male users and more lenient towards female users. But you could argue, if you're looking at the overall performance of the model, that the model itself isn't really perfect in any sense of the word. So yeah, if you're going to use Fairlearn in that context, I highly suggest that you first have a conversation with your customer about what the expectations are and what the context is to the problem that you're trying to solve, and then decide what you should look for in this graph and in other metrics that you can gather from your machine learning model. But at least know that this is how this works. So groups are shown in these horizontal bars, and then on the right you can see under and over prediction. Under prediction means it should have predicted a positive outcome, but it's negative in reality. And the blue one says, well, we predicted a positive outcome, but it should have been a negative outcome. Okay, so that's one way of looking at model fairness, and we can see it's not good. It's not going to fly. The second method that you can employ to look at model fairness in this case is disparity in predictions. Disparity in predictions is a slightly different approach. So what it says on the right here is it says the bar chart shows the selection rate in each group, meaning the fraction of data points classified as 1. I can see that when I split my data set in half for male and female users, that male users are more likely to be predicted as defaulter versus female users. In 18% of the cases, male users are predicted as defaulter, so they're not going to get a credit card. In 10% of the cases, that's the case for female users. So this confirms what I've seen before, but the difference with the previous graph is that we're only looking at a positive outcome of the model. And sometimes this is a better way of looking at things than the other graph because you're only interested in a positive outcome. In this case, however, I'm interested in a negative outcome because that enables people to get a credit card. But the trick here is that if you have a binary classification model like we have here, so I can either say, yes, it's a defaulter, no, it's not a defaulter, I can switch those groups around. I can say, well, in this case, it's less likely that someone gets a 0 rather than a 1 from the model. So that's the same thing, actually. So that's how you can measure fairness. So you can it's not a whole lot of code that you need to use to get a Fairlearn dashboard. And the dashboard itself, once you spend a little bit of time reading the documentation and these graphs, you get a pretty good sense of what's going on with your model. But now the question is, how are you going to fix that? Well, let's talk about that next, because it's no good if you treat one group as lessers compared to the others. So when we talk about improving model fairness, there's actually a couple of ways to do this. If you have an existing model, then you can use Fairlearn to improve the fairness of the model. But if you don't have a model yet, you can also use Fairlearn to improve the training process. Today, however, we're only going to talk about improving models once you have a trained model. The other method of improving fairness while training the model yields similar results, I have to say, and it looks pretty much the same as the stuff that I'm about to show you. So I figured, well, I could build another demo for it, but you can figure that out on your own. And if you have any questions, don't hesitate and give me a yell on Twitter or on GitHub, and I'm happy to help you out with a piece of code that should get you going. So when we talk about improving models after we've trained them, there's two ways of fixing the problem. Well, improving the situation, I would say. So Fairlearn allows you to either use equalized odds as a way of improving your model or demographic parity. What does that mean? Well, Fairlearn tries to do an interesting technique on your model. Basically, what it says is when you take the model, then the reason why the model is unfair is because your model relies on a sensitive attribute directly or indirectly. So the output is dependent on a sensitive attribute. You don't want that. So Fairlearn allows you to disconnect the two, to disconnect the sensitive attribute from the outcome of your model. So it makes it equal for all groups of users. And there's a couple of ways to solve that. So let's dive in and talk about equalized odds first. So this is one of the techniques that allows you to disconnect the input sample, the sensitive attributes in your input sample from the outcome that you get. In this case, equalized odds says, well, there's an equal chance that you get a specific outcome, either 1 or 0, for all demographic groups. So in this case, the disparity in performance, so the accuracy, is equal for men and women. So in this case, 70% chance for a male to get a credit card and 70% chance for a female to get a credit card. There's no difference between the two groups. This is regardless of whether you want to predict 1 or 0. So it's the same. So there's 30% chance for a male to get get a credit card, and so 30% chance for a female to not get a credit card. This works in some cases, but not in all cases. So if you're interested in only one outcome of your model, you have to use a different technique. So that's called demographic parity. Demographic parity says the outcome of the model is not dependent on the sensitive attributes. So to put it differently, if your model is going to predict a defaulter, so someone is not going to get a credit card, then given that outcome, the chance for a male to get this outcome is equal to the chance of a female getting this specific outcome. But for someone who's not going to be a defaulter, we're not going to look at that at all. So it could well be that you have a 70% chance of a male getting a credit card, but there's a 36% chance of a female getting a credit card. But for both groups, it's 10% that they're not going to get a credit card. This sounds really weird, but this it's just what you're interested in. So in this case, I want to make sure that both groups get an equal chance. So we're going for the equalized odds and not for this demographic parity. But in some cases, this might be useful to you. Also, you could think about this in a different way. Removing gender from the dataset doesn't have any effect on the outcome of the model. That's basically the idea behind this. While if I remove gender from this dataset that you use with equalized odds, then it might have an effect because it could well be that Fairlearn tried to train on that one. So let's take a look at the code again. It makes the most sense, I think. So we've just seen that our model is doing okay-ish. It's not the best in the world. We have some differences in fairness. So let's see how we can fix that. Again, I'm loading up my model and the dataset that I use for training this time. Because what's going to happen is we take the original model, wrap the Fairlearn package around that, and Fairlearn is going to train another layer of machine learning on top of my model. And that's going to improve the fairness of my model. And I'll talk about that, about what that actually means for your model in a minute, but let's keep that in mind. So let's get started and see what happens. So I pull up my datasets. Let me fix my small problem here. Because I dropped the ID column and I have to put it in here as well, which is fine. So now I've got my dataset prepared. Let's do this as well. Basically, what happened in my dataset that I've got a little bit of an imbalanced dataset in the sense that there's, I believe, a few more samples that contain data for male users for positive samples versus negative samples. Otherwise, it's pretty balanced, but it turns out that, yeah, that's a problem. So I want to make sure that I've got 50% samples with a positive outcome and 50% samples of a negative outcome in this case, just to give my model a fighting chance to learn anything. So now that we've loaded up our datasets in our model and made sure that it's working, that it's all ready to go, we can talk about the threshold optimizer. This is the component in Fairlearn that's going to help you improve the fairness of your model. Basically, what it does is it adds another layer of machine learning around your model. As you can see here, it's coming from the post-processing module in Fairlearn, which means it's a post-processing algorithm. So we can do that. We can import it, and we can fire up the optimizer, saying threshold optimizer, feed in our original model, and set constraints that need to be solved. Because you could talk about equalized odds and demographic parity as a set of constraints that you apply to your model. And we're going to try and solve those constraints, which is basically what machine learning does. So let's load this up. And then what we have to do, once we have this optimizer, we can fit it, we can train it on our balanced data set, where we feed in the samples and the targets. And we tell it, well, dear optimizer, I know my gender column is causing the problem, so could you please optimize for that? So let's see what happens. But this will take a little bit of time. Oh, it's pretty fast today, so it's pretty cool. So what you have now is a new machine learning model that contains the original machine learning model. That's good to keep in mind, because if you want to go to production with a more fair model now, you have to save this optimizer to disk and use that instead of the original model. Otherwise, it's not going to work. It doesn't change anything in your model itself, actually. So that's kind of cool and weird at the same time, if you ask me. So that's good to know. So once I have my optimizer applied to my model, it should be better. So let's see what happens. Okay, let's grab this widget again, the Fairlearn widget, and call the model. And it says to me, sorry, no can do. Oh, I've got one feature missing. Oh, right. Yes, my ID column is no good. Try this again. I did something wrong here because I decided to drop the ID column from the dataset, which you would normally do. I did it all over here, but I forgot it in my balanced dataset. Sorry. So I fixed it now. Let's see. I've trained my optimizer. So now that I've dropped the ID column from my test set, that's this one, and from the model, it should be fine. So let's see. So I'm selecting the sensitive feature again that we've talked about earlier. I'm selecting accuracy again because that's the metric that I've used across all my training operations. And let's see what happens now. And what you can see is that when we look at the first graph, we can see there's a difference of 5% in performance between men and women. Let's compare that to our previous notebook and see what it did. As you can see, in my original attempt at training this model, it was 8%. So there's a difference between the two. A lower disparity in accuracy means that my model is less unfair. It's a more fair model, but it didn't solve the whole problem. So you might might have to put in more work to fix the other issues that this model has. Overall, we can see, however, that our performance dropped. And this is something to be aware of when you're trying to train models. While Fairlearn fixes, well, at least it improves the fairness of your model, it will also mean that it will overall perform less well. In the end, you might have to gather better data that's more balanced across male and female users, across different values for marital status, age, that sort of thing. So, but at least Fairlearn provides you an insight into what's going on, and it will show you that your model is unfair. And now you can start looking at things like getting better data samples to fix the problem in the end. And if you can't get any better data samples because of many reasons, this will help you at least mitigate the problem to a certain extent. So that's good to keep in mind when you're working on machine learning model. Fairlearn is the secret to at least finding unfairness in your model and mitigating it to a certain extent. So for me, it was a real eye-opener. I thought that fighting bias in AI models would be very, very hard for me because I'm not a data scientist from day one. I used to develop regular software with if statements and while loops and all those things. And I started working on machine learning as a sort of a side project while working on a knowledge management system. That's how I got started. And I didn't know about fairness. And I'm not well versed in the whole statistics things. I know the basics, but stuff like this is very hard. If you look at the formulas that these people use, oh boy, that's a nightmare. And I'm just happy that they made a tool that helps me as a developer get the insights. And even if you're a data scientist with a PhD or someone very, very bright, this is still a good use because, yeah, it saves you time. So that's what I have to show you today about Fairlearn. So just to keep in mind, Fairlearn is free and open source, so you can get it from GitHub. You can even submit changes. My code is also in GitHub, so you can download the demo if you want to. I guess we'll put a link in the description, right, Sammy?
Yeah, we can copy it. I'll copy your GitHub link to the comment section. so people
Yeah.
can.
So we can do that, and yeah, go try it for yourself and see what happens to your machine learning models.
Cool. Thank you very much, Willem. Indeed, it's a very interesting new service that Microsoft is offering, at least the library that they built it. Am I correct? It's open source also?
Yeah, it's fully open source.
Yeah.
So if you feel that something's broken or maybe the text could be clarified or something like that, feel free to submit changes if you have them. They're quite responsive, I have to say.
That's nice. I see. Okay, don't have questions, but people are thanking you. I'll share your GitHub URL on all the streams that we are having. So what do you think in the future? Do you think everyone will start using this kind of packages to optimize their models, or you think there will still be companies who are like, I'll just ignore this and do my own shit?
There will always be companies that don't mind what they're doing, solely for the fact that it puts them at a disadvantage. So one of the challenges that I got asked about a lot is, for example, some countries use AI in ways that might be illegal in other countries because of privacy concerns, and also because of fairness issues. We've all seen the samples enough, I think. So those companies that work for those countries might not be very interested in this, but I'd like to assume the positive. So I think more people will start to use this soon and start checking their models for fairness issues. And I know Microsoft is doing that with things like cognitive services as well. So if you're using custom models in Python, I highly recommend this, and I think a lot of people will start to use this. If you're using cognitive services or ready-made models, it might still be useful to you, although I don't think you can use this against cognitive services, so that might be a challenge.
Well, I know for example, for facial recognition, that there are specific rules also that Microsoft are setting for using it, just based on the Fairlearning. So, well, not specific on the package, of course, but just to have to be able to use it in an appropriate way. So I think packages like this should be in your pipeline of building a machine learning model if you're using privacy-related data or personal data.
Yeah, it's an important topic because I think that so we're currently at the stage of AI usage where you could say that companies are getting aware of the fact that they can use it, and next step will be: are we using it in the best way possible? Are we empowering humans or are we limiting humans? For me personally, that means that in my daily work at InfoSupport, I'm using this stuff already because I find it's very important that the components and models that we build for our customers are fair. Otherwise, it's no good, and we're not going to do it. The problem, however, is the drop in overall performance of your model. So you have to be aware of that, and that provides an additional challenge for us that we have to overcome. But as I mentioned, better samples will provide you a more fair model and better performance overall. So it's fixable.
Over time, you will collect also more data, and that might improve it again. So
so the first model is never the best one. This is an iterative process. Agile is certainly a thing that you have to use in this process.
Exactly. Willem, thank you very much for your very interesting talk. As usual, every week we have another speaker, and also next week we have someone else, and we will be having on board Menaka, and she will be talking about Azure AI for .NET Core developers. So if you're more a .NET developer, well, please join us, and you will know more of how you can implement AI within your applications.
Cool.
Yes. So, Willem, thanks a lot. I'm sure we will hear each other soon again.
I guess so, yes.
And for all the rest, have a good evening, a good rest of the day. And thanks for joining us. Bye-bye.
Yes, see you next time. Bye.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Excellent Sammy in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Test. I come from
I'm
Spanish.
Prasant from California.
大家好，我是卢建辉，Willem Meints.
I'm Fantasy from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, ismini Ali Daoud. Biz Africana.
Hi, I'm Ana Romana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there.